This is question number 47 from the mid-semester, and it was only for the civil mechanical students. But hopefully this will be useful for everyone because it's quite a common thing that we work out, the parallel and series systems. So just going to quickly go through this again. For a series system, what you have to remember is that the likelihood of surviving to a certain period of time requires both of the components here to survive to that point. In other words, if any one of them fails, then the whole thing fails. So the reliability of the system has to be the probability of the first one surviving multiplied by the probability of the second one surviving. So the reliability of A is going to be equal to 0.9 times 0.8, which equals 0.72. For this one, we've got a parallel system. Now, for a parallel system, it keeps on going if any of them survive. So for them to fail, so the probability of failing has to be equal to the probability of each one individually failing multiplied together. So the probability of failure by a particular time for the system is the probability of one failing multiplied by the probability of the other failing. And what's the probability of failure, or the cumulative probability of failure, capital F, is going to be equal to 1 minus R, because R is the probability of not failing. So in this case, the probability of failure is going to be equal to 0.6 times 0.3. So failure B at any particular time is equal to 0.6 times 0.3, which equals 0.18. And note that we've calculated the cumulative failure for the system. Well, we actually want the reliability, which is equal to, if you just rearrange this again, R is equal to 1 take F. So if we say, reliability of system B is equal to 1 take 0.18, which equals 0.72, the same as the first one.